Thank you for staying around. I understand that there's dessert going on. So, okay, you're still here. It's not a mistake. Good. Thank you. Appreciate it. Just to say thank you, I have this wonderful picture of the stadium. We are right there in the window, so if you do that, no, but it's close enough. All right, so we're going to speak about Docker image lifecycle, and first of all about me, as was presented, I'm Baruch, developer advocate with JFrog at JBaruch over the internet, and this is the precise definition of my personal and professional life. This is what I do, basically. So, show notes, just go to jeffrog.com/show notes. You'll find there an entry for DevopsDays Austin with this talk. The video, I'm recording, hopefully I will upload it later today. The slides are already there, a bunch of links about the stuff that I talk about, a feedback form to say how did I do, and as a thank you for being there, a little raffle, and if you come early, there are additional perks in there. JFrog, first of all, we do awesome t-shirts. If you didn't get yours, you should go. We're over there at the table, and those are good t-shirts, right? Except of t-shirts, we also do software. JFrog Artifactory, JFrog Bintray, JFrog Mission Control, and JFrog X-Ray. I won't talk about any of those. You will come to the table to get the t-shirt, and we will get you there. Poll time, and that will be a very fun experiment to run. I do it a lot, and the results are not surprising every time. Let's see if I get surprised this time. So you vote, and then you keep your hand up until it's not relevant to you anymore. Who heard about Docker? Everybody, hands up, keep them up. It won't take long, you will get to your dessert very soon. Who can do the tutorial, did the tutorial, think can do the tutorial? All the same hands, very good. How about POCing, I tried it, played with it, almost everybody, good job. How about Docker in production? Okay, take your hands down, don't lie. Okay, well, not surprising. Look around, 1, 2, 3, 4 hands. Right? That's exactly. And since I knew it was coming, I have a slide which is that. So there are a lot of reasons why we are still hesitating in taking Docker to production, and it's not because it's a bad technology. It's awesome technology, and we're going to talk about our relationships with Docker very, very soon. But one of the reasons why we believe a lot of companies and a lot of people don't take Docker in production is that. As I mentioned, it's awesome, but it's also kind of scary. It's another level of obscurity in our stack. It's kind of a container that something is going on there. How can we be sure that whatever running in this container in production is exactly what I thought it is? So we like this concept of integrity and being sure that whatever runs out there, it's exactly what I put there. And today's talk is about fixing that. This is what I will try to do. My relationship with Docker, if you wondered, it's the frog hugging the whale. We really love Docker. It's a hug. With that aside, we think that Docker is a very important technology that never comes along. This is, of course, Solomon Hykes speaking at DockerCon 2015, more than 2 years already, on stage and asking this question: who's using Docker and nothing else? In terms of there are no other technology in the company except Docker. Anyone? No hands. It was like 5,000 people, no hands. And that makes perfect sense. The analogy of containers works perfectly here, and no one actually ships empty containers, right? There is no money in it. And exactly the same with software. We always put something in our Docker containers. And JFrog here represents a company that does a bunch of universal solutions and work not only with Docker, but with everything about Docker. We do it for 12 years. We manage binary files, including Docker images, and that's why I think I can stand here and advise you on how to build your pipeline better. And this comes from experience. We're software engineers. All we know is search for a pattern and then check if it's applicable or need to change. Docker, no change. We still need to see if there is a pattern there, and if it is a pattern there, should we change it? And Docker images, pipelines with Docker images are not different or shouldn't be different than any continuous integration, continuing delivery pipeline we do, and we do them for years. And this is the promotion pyramid, which is like a multi-dimensional pyramid trying to fit into 2 dimensions. You have here a number of builds, the time it takes to do the whole build with the test and everything, and the pipeline itself. So in the beginning we have tons of builds, we run very fast tests on them, unit tests, and some of them fail and some of them survive. And then we have less builds, longer tests, some of them fail, some of them survive, all the way to production through manual QA, which is very long, but very few of the builds go there, etc., etc. Or the same picture from the different direction. This is how we do the pipelines for any technology. We take the binary files as they are out from our continuous integration server, and then we start promote them through quality gates. Quality gates are those various tests, and we promote those binaries all the way until they hit the production environment. Right, again, this is no new, shouldn't be new to any of you, and if it's new for you, don't admit it. So I'll take it, everybody know it? Yes, great. Now let's see why we cannot do it with Docker. One of the reasons is how awesome Docker build is. Docker build is an extremely powerful command, an extremely powerful declaration language or markup language, or call it whatever you like, which is like Chuck Norris. You can do everything with Docker build. Right, and now especially with those multi-module cascading builds, it's even more powerful. And the problem is that when we have something like that, what we want to do naturally is Docker build all the things. So instead of promoting the binary that we built once, we tend to promote a Docker build file and just run Docker build in every environment. Now, this is very tempting because promoting a text file is super easy. All you need to do is tag it differently in your version control, and you're done. You retag it, and you're on the next level. You build it, you get new image, and you have a new image for your new stage in your promotion pipeline. Sounds like a great idea, and it's not. It's not a great idea because faster and cheap builds are not always the way to go. And this is, if I remember correctly, Shanghai, China, and they excel in fast and cheap builds. Most of the time they're good, not this time. Anyway, that's a very bad idea because of that. Now, when I prepared this talk, I wanted to craft a ridiculously fragile Docker build file. And then I just went to the internet. And I realized I don't need to invent anything. In the show notes, JFrog.com show notes, there is a link to this file in GitHub in someone's repo. It's super popular. It has hundreds of stars. People use this in their Docker environment. And of course, this is horrible because every line here is a dependency to a latest version. And here you all experience with Docker. Some of them even claim that they use it in production. And this is where you should tell me, but we can fix it. It doesn't have to be like that. If someone does it wrong, it doesn't mean that we should do it wrong, right? And it's a great idea, and I think we can fix it. Let's start with the from statement. How we can fix the from statement? Yes. Version, right? Oh, that's obvious. Let's put the version. Here we go. Any better? Not really. Why? Oh, thank you very much. The build for Ubuntu 14.04 is updated every time, which is heresy for what it's supposed to stand for. A release version should be immutable. We all know that, right? But it is updated every time, and for a good reason. The reason is security. Thank you very much. 14.04 means April 14th. April 14th was 3 years ago, exactly, right? And what happened between 14.04 and now? Security related, something very big, affected Ubuntu. OpenSSL, Heartbleed, thank you very much. Now here we go. We have tons of servers on 14.04, which all of them are affected by Heartbleed. And Canonical, the guys, the awesome guys that maintain Ubuntu, have a dilemma. They can stick to this notion of a version means immutable binary. We cannot change 14.04, and we will wait until the internet will upgrade, which will be somewhere in the next century, or we can break this promise of immutable version and push some security updates into it. So 14.04 that at least downloaded from today on will have this security fix. And of course the later is the right thing to do, but for us it means we cannot rely on the release version of Ubuntu 14.04. Any way to fix that? .03, I think that the security versions go into very, like a lot of numbers after that, so it won't help. Huh?
Make your own private repos.
Private repos, make your own, thank you, we will get to that. Very simple fix, we can use ID number. ID number in Docker means checksum. Now this is great. This actually means a reference to a very specific file, a very specific Docker image, which is Ubuntu what? Any idea? I think I just sat on my keyboard and this is what came out. You basically have no idea what this checksum refers to. So it's very, very solid, but completely useless. Okay, let's go to the rest of them. How do we fix all those apt-get stuff? Huh? Add a version. Perfect. Thank you very much. Yeah, so we can fix that. How do we know that we can add a version to apt-get? Just because we know how apt-get works, right? And we're really lucky. But how many of you know Java? Oh, very few. That's good. So how about that? How about that? Is it like solid? Is it mutable? Immutable? Can I make it mutable? Can I spend 5 years of my life learning Maven to the level I can make it immutable? Probably yes, but you're not wrong about that. How about that? What I mean is, there is no reasonable way to build a Docker file which will always be immutable and will always, in 100% of the cases, omit the same Docker image. And that's why we have this feeling that every time I run Docker build, I am not quite sure I'm going to get exactly what I wanted to get. And that's okay if we do it one time and we know that we will run a bunch of different tests all the way to production, because we will have all those quality gets that will verify that whatever I want there is actually there. But when you run Docker build in production, this is very scary. So instead of doing that, we need to apply another pattern. And that pattern, of course, is the immutable server pattern. Who knows immutable server pattern? Oh, not enough people. Okay, so I will tell you about immutable server pattern. Traditional server means, you remember we have this hardware that we had to buy and install, and we had those servers, and every time we need to reconfigure it, we actually log into this server and apply some configuration. And you know exactly why it's bad, because we have to manage state. If we have multiple servers, how we make sure that the state is the same? If we need to apply some changes, how do we know which changes been applied and where we stand? And there are a lot of bad things about it. But that's the only way we could use a physical server. Nowadays, we can throw servers away because they are infrastructure as code, and we can dispose our servers and create new ones as we want to. So after we created the server, we never touch it. It's immutable. If we decided that this configuration doesn't serve us anymore, we will create a new server with a new configuration and throw the old one away. So this immutability is something that we can learn from the runtime, and of course servers are about runtime, and take it to our continuous integration and delivery continuous integration and delivery process. Thank you. So all we need to do is promoting immutable and stable binaries. And this is what I've been talking about for the last 15 minutes, but it's not very easy with Docker. This is what we want to do. We want to build it once and then promote it through those quality gates all the way to production. And now, before we talk about how we apply to Docker, that's where you should ask me what's up with the gates, why I keep talking about those quality gates and why they are so important. And they are so important because strong quality gates is the only way you have to ensure that QA don't see dev images that didn't even pass automatic tests, and you won't get non-tested images into stage environment, and of course, the most important, you won't get non-stage, non-test, or dev images into production. The only way to ensure that is very strong quality gates. When we are talking about Docker, means different registries for images, because the only entity for which you can configure good access control is the registry itself. So we're going to talk about that. How can you implement it so it won't be very painful, but think about it, you need those quality gates. And now let's talk about why it's so fun to implement it in Docker. And it's so fun to implement it in Docker because Docker have some limitation which is, I would say, not exactly justified, exactly like that limitation was. And that's Docker tag. Now, tag refers to a name of the Docker image. And this is how it's built. It uses the host, only the host, and then it uses a slash separator, / to separate between the host where the image comes from and the image name. Now there are two questions in it. First, why the hell we want to include the host in the tag, in the image name? There are very good reasons to do so. You can immediately see if you are dealing with official image that doesn't have this prefix, or my own image that comes from my repository and then my registry and then have to have this image, right? So there are some very good reasons to justify that, but the / I don't know, like, it's already been taken. It's a character that we already use for other things. And one of them is separation between the host name and the path inside the host name. Because if this / I cannot use it to express multiple repositories or multiple registries in my single host, how can I support multiple registries or multiple repositories in a single host? So how can we support that? And that is your normal way of working with repositories in Artifactory. You have repository for dev, repository for QA, for staging, for production, and they are inside a single host, separated by this / How can I do that? And that's not an easy problem to solve. It's not unsolvable, and I will show you the solution in a second, but it's kind of, it's in our way. So that's, of course, one solution to this problem that you all should refer to when you hit it, but there is other. And we can use virtual hosts and or virtual ports to emulate multiple hosts or ports under a single physical host or port, right? So what we want to do is, this is the command, docker tag, host port, and then the name, which is translated over the wire in the protocol into host port, and then v2, doesn't matter, and then the tag name. And what we need to do is build that. We need a context name. We can get rid of context name, but it won't really happen, because after the host name, we have this repository or registry name that we need to have. And this is done by URL rewriting that you can get from any modern HTTP server. That's example for Nginx. The same can be achieved, of course, with Apache, with HAProxy, and any other. And you can see here that this configurations listens to a virtual port, to port 5001, and then whatever comes there, it will translate to a full URL that goes under Docker Dev. And it will be the same for another port that goes into Docker Staging and another port that goes into Docker Prod. And here we have multiple registries happily live under a single host because we use those virtual ports. So that's the solution for this problem. Now, next problem. Since we have the registry host in the tag name, in order to promote an artifact between one registry to another, I need to pull it, re-tag it, and then push it back, which, considering the size of Docker images, is a process that I'm not sure we really want to do. And there is a solution for that as well. So here's an example of Artifactory, but I guess you can implement it with other tools as well. And what you can see here, and that won't work, right? So I will use a mouse here. Here we go. What you can see here is multiple repositories. Those are our registries, which are aggregated under a single virtual repository that actually delegates to all those behind the scene. And then when we want to deploy, I lost the mouse again. I don't know where it is. Here. No. Here. And then when we push a Docker image here, it will be deployed to where we actually start, the Docker Dev. All those are valid Docker registries. Our tools, our environments, our QA, etc., can use any of those to interact with them directly. But then, when they're ready to production, we can back this virtual repository by the production repository and expose a single point of interaction between our users or developers and then the consumers of those Docker images, and bunch of different repositories right here that any one of them is a valid Docker registry. The promotion between them is done by a simple REST API. Nothing gets dragged between different hosts. It's actually not even moved inside Artifactory because we use checksum storage, so all we do is change the reference to this file so it will look like it's under a different registry when actually it's free and cheap. So, just to sum it up and to give you another pattern on how can you build your continuous integration and design pattern and design pipeline with Docker, Let's talk about a typical container. This example we use Java, that as you admitted none of you almost know, so that will be a lot of fun, but the principles are the same and I'm sure we all will be fine. So starting from the bottom, we have some base image, and that example is CoreOS, the previous was Ubuntu, doesn't matter. And then we have some framework. Our framework is our runtime environment. In case of Java, it will be JDK, plus some application server or web server or whatever you want to use. And on top of that, we have our application file, which in this example, again, it's a WAR file, but of course, can be anything that makes more sense for you in your case. And we have two builds that take care of all the layers. First will be the framework build. The framework build will be a verified-based image, and we were going to talk about what verified-based image means and why it's different from any other. We add system dependencies, like the JDK in my example, or the ones that make sense for you, and they come from the trusted source, or Gfactory, or whatever repository you trust. In our example, it will be JDK and Tomcat. And the most important part of it is that you own your image. If you have to, and if you have no system dependencies to add, that will be your base image. All you do is you take an official image from the repository and you start to control the cycle. Now, any update that will come to CentOS 7 in our example won't affect your build. Your build will be more stable. Once in a while, when you want to pull an update, you can build your framework again and it will take the latest CentOS. But until you do that, your application will always have the same base image regardless of what's going on with the CoreOS 7 image. On top of that, you add your application build, and you use your framework as your base, as we spoke, and then for our example, you run a Java build, you get this WAR file, and then you add single file to your base. The less your application build changes, the more stability you gain when you run this application build every time. If you want to change other things, they belong to the framework. Take them with the build of the framework, change your framework how frequently you want, but for the application, one file. Or, the bare minimum of files, in our example, one. And that will be all. And this is our example again, so you can see here we use our own framework, the from line. And then on the third line we add one file. We go to our repository, our Gfactory in that example, and we take the latest WAR we can trust. It's in the release repository, we can trust it. We know it's good because it passed all those quality gates that I have spoken, so I can take the latest there. The latest there is safe, and then I add it to the place where those files should go in my framework. Right? And here we need to discuss a couple of things. First of all, should I take it from the release repository? And that depends on how you build your pipelines. If you test your application outside of the Docker image before you put them in the Docker image, then those applications will have their own pipeline. They will have their own dev, their own QA, their own staging, their own release, and you take it from there. If you only test your application with the container, which makes sense in a lot of cases, then you will have one repository of your application. It will probably be dev. You will put it in the container, which is in the dev repository, and we'll test them together from there. So another example, it comes from release, but that can vary. Now, we rely on the latest version of the app there. We take the latest. And we take the latest because we tested them and all of them are good. So we can definitely take the last one in there. And here you should say, okay, we just spoke about not relying on the latest and from, and here we are. And the difference is, this is ours. You remember, we own this base image. It won't magically change overnight because someone pushed an update. It will only change when we run the framework build. Now, after we run this framework build, we want the next application build to take the latest because we want the latest changes that we just did. This is why it's okay to rely on latest for our own base image. Also, we need to verify that latest is indeed latest, but that's a discussion for a whole new different talk. How do we test those things? Here's another pattern that you will learn today, and that's a sandwich testing. Anyone heard about sandwich testing? No one ever heard about sandwich testing, so now you will. Sandwich testing is an integration testing pattern that it's a real thing. It can be found in Google, and you know that whatever can be found in Google is always right. And especially when they bother to do this thing on top of search results, that means it's like verified, it's no fake news, verified. So this is verified, and there is a thing called sandwich testing, and if it wasn't, now there is. It's when you take bottom up and top bottom and merge them together. Now, I have no idea if it's really a thing or if it's even applied to what I'm going to show you now, but you know. So here are our two pipelines, our framework pipeline and our application pipeline, and we test one of them with another. So, as I mentioned, we always take the latest framework to test our application. If everything works as expected, our framework is good. And the other way around. We can always take the latest application to test our framework. And if everything works, this is good. And here you should ask yourself, will we get to that? When the framework breaks the application at the same time breaks the framework, and everybody dies. Well, theoretically, it can occur if both the changes that you apply in framework and the changes that you apply in application are not backwards compatible. That means that you need to make those changes in the same time. And that should never happen. If that's not the case, if at least one of the sides is backwards compatible, all you need to make sure is that you always test whatever you just built before you trigger the change in the other build. And then, if you have your triggers set up right and your build triggers all the tests, you can be sure that this deadlock will never happen. So, just to conclude, a continuous integration and continuous delivery pipelines in Docker are possible. Not only they are possible, they can get your level of confidence with Docker to a new level when you're actually more secure about what's going on in production, and that of course helps you to release fast, and that's always a good thing. So here you go. Now I have a very nice background here for this slide, and that's a clue for me to remind you that in 3 weeks we have our own JFrog user conference, Swamp Up in Napa. And that's a picture of Napa. Yeah. You should come. It's in a gorgeous resort, wine, good conversations, always, good DevOps talks. You should check it out. Again, in our table. Baruch, that's me. DevopsDays Austin or DevopsDays, I'm not sure which is the right and official hashtag. Let's go with the more specific one. Show notes, just to remind you. Video soon, slides already there. All the links, including to the sandwich pattern. That's important. Feedback form and raffle for being here. So thank you very much, and I'm done. Thanks. Which one works? Oh, okay, mine works. We have 2 minutes for questions. Anyone?
Questions?
Yes.
Retag the same image with different URL?
Can I retag the same image with different URL? The problem is that if I want to have multiple registries under the single host, it will be the same URL. because in the Docker tag, I can only have the host. So that's the problem. If I had the full URL, then I would do a lightning talk instead of all that. 5 minutes would be out of here.
Yes.
Yes.
Maybe a follow-up to that would be, if you just change the username between your dev stage.
Yes. So in Docker tab, thank you, and the question is, can we use a username? So going back to this tag real quick here, yes. So look, there is something else in this syntax, and that's the URL username that sits between the registry host and the name. And we can abuse that for specifying the right registry. Yes, we can abuse that, but that will be an abuse. And that's not a good idea because those tags are eventually public. And if someone who knows that it should be a username sees a prod there, they're like, okay, there is a guy and his name is prod and his parents hates him, right? Because he's called prod. Yeah. So we could use that, but anyone else? Okay, and now we're officially out of time. Thank you.